Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 11.1, Simplifying Radicals Involving Products. The first thing we're going to look at is the multiplication property for square roots. What this says, for every number that is A is greater than or equal to 0 and B is greater than or equal to 0, basically what this means is they must be positive. We have a property that states that I can take the square root of a times b, and it is equal to the square root of a times the square root of b. I can basically take any number that's inside of a square root, just like the example here, the square root of 54, and I can split it into two factors of that number, like the square root of 9 times the square root of 6. Once I have that split, I can split it into a perfect square and a not perfect square, which the square root of 9 is a perfect square, the square root of 6 is not. Once I have done that, I can actually evaluate the square root of 9 and make that 3. That is what we're going to be doing today. So let's go ahead and make a list of these steps that we are going to use. So step 1, we're going to look for perfect square factors of our number. You can use a factor tree in order to do so if you feel like you need to, okay? Then we're going to split the square root into the square root of the perfect square and the square root of the non-perfect square. So we're going to split it into a perfect square factor and a non-perfect square factor. How you figure that out is you're going to take your overall number and you're going to divide it by the perfect square factor. Okay. Then we are going to evaluate the perfect square factor. What I mean by that is the step that earlier we talked about where I took the square root of 9 and made it 3. Then finally we will leave the non-perfect square alone. So let's go ahead and dive right into this. The first example we have here is not exactly the easiest one to figure out what a perfect square or a not perfect square would work into. So what I would suggest you do is go ahead and take the 192. First, check and see if it is a perfect square. We know that we find out that it's not if you take the square root of 192. Then what I would do is I would take 192 and divide by 2, see if that's a perfect square. It's not, then I would divide by 3 and see if the number that comes up is a perfect square. In this case it is, so what I could break the square root of 192 into is the square root of 64 and the square root of 3. If I take 192 and divide it by 3, I end up with 64. Now, knowing that my square root of 64 is a perfect square, I can go ahead and evaluate that. I end up with 8 root 3 for my overall answer. B is a little easier for us. 50, most people know how you can multiply to 50, and they know that 25 is a perfect square, so I can take the square root of 25 and the square root of 2. Well, the square root of 25 is 5, and the square root of 2 will just stay the square root of 2. Okay. On to C. You got to think about perfect squares that are factors of 27. Well, 9 is a perfect square factor of 27. 3, if I take 27 and divide by 9, I end up with 3. So 9 times 3 would get me to 27. Now, in this case, we do have a variable involved. What I'm looking for when I'm taking the square root of a variable is groups of 2. How many groups of 2 do I have? So in this case, I'm going to split my variable into the number of groups of 2 that I have. Right now, I just have the one group of 2, the x squared. So I'm going to leave it that way. What I can do at this point is evaluate my square root of 9 for 3. Looking at our square root of x squared here. What really ends up happening is, since it is a group of 2, the square root and the squared will cancel, leaving me with just an x. Another way to think about that, if I had x to the 4th power, that would come out as x squared because it's 2 groups of 2. Finally, I'm going to go ahead and leave the square root of 3 alone, and that's my answer. On to D. Again, we need to break up that square root of 45 into a perfect square and a not perfect square. So I'm going to leave the 3 out front for now. I'm going to take the square root of 9 and the square root of 5. Okay. Again, I'm going to leave the 3 out front, and that's going to multiply by the answer of the square root of 9, which is also 3. The root 5 is going to be left alone. So 3 times 3 is 9, root 5. And we are done. On to E. Again, think about what is a perfect square and a not perfect square that are factors of 28. Well, I can break 28 into the square root of 4 and the square root of 7. X to the 10th. This is where I was talking about the groups of 2. How many groups of 2 do we have? Well, I can break x to the 10th into x squared, x squared, x squared, x squared, and x squared. That shows me all 2, 4, 6, 8, 10 different x's, right? Well, before we continue with the x's, let's look at our numbers only. The square root of 4 is 2. Now the square root of 7 is going to stay the square root of 7. Now for our variables, again, we want to know how many groups of 2 do I have. Well, in this case, I have 1 group of 2, 2 groups of 2, 3, 4, and 5 groups of 2. So that means I'm going to take out an x to the 5th power. And that will be our answer. Okay. On to F. I'm going to actually need to move to erase a little bit of this. So if you need to go back and look at the rest of that problem, go ahead. How can I break up? I do not right now want to multiply the 8 and the 12. I could if I wanted to. I could jump straight in and take 8 times 12, and that would get me a whole much bigger number. Or I can break it down right now the way it looks. So I can take 8 and break it into the square root of 4 times the square root of 2, and I can take the 12 and make it the square root of 4 and the square root of 3. In between those two, I'm still going to have a multiplication problem. So looking at the first group, the square root of 4 and the square root of 2, the square root of 4 is 2, the square root of 2 stays the square root of 2, times. Now looking at the second group, I have the square root of 4 times the square root of 3. Well, the square root of 4 is 2, the square root of 3 stays the square root of 3. At this point, I can go ahead and multiply the 2. So I can take this 2 times this 2, which would get me 4. I can take this 2, the square root of 2 times the square root of 3, and get myself the square root of 6. And I would be done. A lot of different problems like G. The square root of 13 is just going to stay the square root of 13. There are no factors for the square root of 13, so I'm going to leave it alone. But I can break up 52 into the square root of 13 and the square root of 4. Okay? Now, what does that get me? Well, that would get me the square root of 13 times the square root of 13 is the square root of 169. The square root of 4, I'm going to go ahead and put out front, that's 2. Well, before you can say that this problem is done, what you want to do is go ahead and look at the square root of 169. If you take the square root of 169 in your calculator, what you're going to find out is that is 13, which means I can take 2 times 13 and get 26. So there are times that multiplying the 13 and the 52 could have been actually quicker there. However, that would be a different process. We don't always know if that's going to work out perfectly or not. So I would like you guys to continue to break it up, work through it that way. Just double check at the end before you say your problem's done. Double check at the end and make sure that the number that's inside of your square root is not a perfect square. All right, on to H. H has something that's a little bit different of a problem here. We have only variables, which is fine. What we're going to want to do is take the square root of x squared times, now I want to break up the square root of y to the 5th. Well, earlier in the problem right above here, we had broken our x to the 10th into x squared 5 different times. We don't necessarily have to do that. I'm looking for any number of y's that is an even number, because that tells me then it is a perfect square. So what I could do is I could break the y to the fifth into y to the fourth times y. It's the same idea as what we did on the problem above. It's just a little different way of writing it down. If you want to break up your problem like we did in E, go ahead. However, if you like this way better, that's fine as well. So looking at our work from here, I can take the square root of x squared, which is just x, times the square root of y to the fourth would be y squared, times the square root of y, and I am done. Notice I broke that y to the fifth into y to the fourth and y. Y to the fourth is a perfect square, y is not. So that still follows in line with everything else that we've done. What I would like you guys to do now is to go ahead and work on I and J on your own. Go ahead and you can pause the video. What I will do is when you come back, I'll have the answers for you. If you have any questions on it, make sure you ask me when you come into class tomorrow. All right, go ahead and pause the video. Well, there's the answers to I and J. It's 7x to the fourth y times the square root of y. And for J, it's 15x times the square root of 2. Hopefully you did those very well. If you have any questions on those two, go ahead and ask me when you come to class tomorrow. All right, let's go ahead and go to the back. Now in the back, we also have properties for division. They work in much the same way. The multiplication property said that I could split what's inside of the square root into two separate square roots, or I could go back the other way. That's the same thing with the division property. The division property says for every number, a is greater than or equal to 0, and b is greater than 0, because it cannot be equal to 0 since it's in the denominator. We can have the square root of a over b, or that can turn into the square root of a over the square root of b. As you can see in this example here, they start out with the square root of the whole fraction. They split that into the square root of 16 and the square root of 25. Well, the square root of 16 is 4, the square root of 25 is 5. It's kind of similar to a while back we were talking about solving quadratics, and you had a book assignment where you had fractions that you had to split like that. Okay, so we can treat it in that way, or we could treat it as one big fraction. It just kind of depends on what's better for us in each problem. So let's go ahead and practice this. I have the square root of 144 over the square root of 81. I can go ahead and split that into the square root of 144 over the square root of 81. Well, the square root of 144 is 12. The square root of 81 is 9. Both 12 and 9 are divisible by 3, so this can simplify into 4 over 3. I would not suggest simplifying right away all the time, but there are some benefits to it every once in a while. You'll just kind of have to play around with it and see what works best for you. On B, again, I can go ahead and split it right up. Well, the square root of 11, there's no way to break it down. I can't make it any more simplified than what it is. So the square root of 11 is going to stay the square root of 11. The square root of 49 is going to turn into 7. And there's our answer. C goes much the same way. Square root of 25 over the square root of x to the fourth. I'm going to keep that as x to the fourth because, like we talked about on the front, the square x to the fourth is a perfect square, so I don't really need to break that down any further. So the square root of 25 turns into 5 over the square root of x to the fourth ends up being x squared, and I will be done on that problem. Let's go ahead and move to the next line. D. Now this changed it up a little bit. We had a problem like this on the front. So what I'm going to do again is split this up to 25x squared times the square root of x over the square root of y squared. Notice I went ahead and broke up the x to the third into its perfect square, x squared, and its non-perfect square, x. So looking at the square root of 25x squared, I end up with 5x. The root of x has to stay over the square root of y squared is y. And I am done with that problem. Now E, again, I can go ahead and just like I did on the last problem, split it up right away. The square root of 75 turns into the square root of 25 and the square root of 3 over. Here I can have the square root of 16 and the square root of x squared. I did write that a little different. Over on D, I wrote that as 25x squared. You can write it that way as long as you understand that it becomes 5x, or you can split it up like I have done in E. It doesn't really matter. It's up to you. Okay. So then we'll look at our numerator. The square root of 25 is 5. The square root of root 3 stays root 3. The square root of 16 for our denominator is 4. The square root of x squared is x squared. Okay. On to F. Now F is a little bit of a different animal. What we do not want ever is to have a square root in our denominator. So if I can simplify my numerator and denominator to keep myself from having a square root in the denominator, I will go ahead and do that right away. So what that means is I can take 88 divided by 11, and that gets me the square root of 8. All I did was simplify my fraction. Technically what that would be at this point is the square root of 8 over 1, and as we know, I can just write that as the square root of 8. Well, now I can break the square root of 8 into the square root of 4 and the square root of 2. The square root of 4 is 2 root 2, just like we were doing on the front side of this worksheet. All right, on to G. Again, with G, 12 and 27 are both divisible by 3. So I can go ahead and change my fraction 12 over 27 into 4x to the third over 9x. All that is still under 1 square root. We know that we can split our square root up, so I can split it into the square root of 4, square root of x squared, and the square root of x for my numerator. For my denominator, I can make it the square root of 9 and the square root of x. At this point, before I do anything else, I want to look for anything that matches. So the one thing that matches is the square root of x. I can go ahead and cancel both the numerator and denominator. If they're exactly the same, I can cancel them out. I don't need them anymore. Okay. Now at this point, I'm going to go ahead and I am going to evaluate my perfect squares. So the square root of 4 becomes 2, the square root of x squared is x, and the square root of 9 is 3, and we are done. H, again, is much like F. You want to go ahead and take 90 divided by 5 and see what I can get. Well, it is the square root of 18. The square root of 18 can be broken into square root of 9 and the square root of 2. Square root of 9 can be broken into 3 root 2. Finally, on J, we are looking for, again, anything that I can cancel or anything that I can simplify. Well, 27 over 3 would become just 9. Then I have x to the third over, well, the 27 and the 3 canceled. The 27 became the 9. What's left in the denominator is just my x. Okay. Now what I want to do is break down my fraction like we've done before. Square root of 9, square root of x squared, square root of x over the square root of x. What can cancel out? Well, the square root of x can cancel out. Leave me with just the square root of 9 is 3. The square root of x squared is x. Well, that has been our note sheet on the multiplication property for square roots. Remember, on the multiplication property, I can take any number, go ahead and split it into a perfect square factor and a non-perfect square factor, which then will allow me to simplify the square roots. Also, with the division property for square roots, I can take a fraction that's underneath one large square root and break it into two separate square roots, which then will allow me to simplify those as well. If you have any questions of this note sheet, make sure you bring them in to me tomorrow. Otherwise, thank you for watching and have a great day.